we have our overlay network, and so what we have to do is create all the services on this network. So we'll start with the easiest one, the Redis service. So Docker service create -- network dockercoins -- name Redis, and then I give the image name Redis. The name will be used for the DNS alias. So that's why here I have to give the name because the other containers expect that Redis will resolve to the Redis container. So if I don't put -- name Redis, that won't work. Okay. One more time. This doesn't mean that Redis is running. When I get like the result of this command, it just means I got your request and now I'm going to be working on it. But since the Redis image is really small, I think if I do docker service ls now, yep, I see that Redis is up and running, like replicas one-on-one. Okay. Now we need to run the 4 other services. So I'm going to do another for loop. So let's see. For service in WebUI, Hasher, RNG, Walker, do Docker service create on the dockercoins network with the name of the service, so -- name $service, specifically so that Hasher and RNG will be reachable with the names Hasher and RNG. Yes?
So do the other nodes automatically check port 5000 to find the registry?
Do the other nodes automatically check port 5000? Yeah, so just to make sure I'm not losing track. Yeah, now I need to put the image name. So localhost 5000 / dockercoins _ $service colon. Did I put 0.1 and v0.1 earlier? v0.1, I think, but I can change if needed. So when I do that, I'm telling to each node, or rather my specification is I want you to run the image localhost 5000 dockercoins blah blah blah. So when a node receives that instruction, it will try to pull the image from localhost 5000. In that case, since we deployed the registry by publishing it on port 5000, I end up with all my nodes talking to the same registry. That's good. But if I were like, how can I say that, playful, I could just run different registries on each node on port 5000 and put different images, and in that case I would get a completely random mix of containers because like on node 1 it would pull from localhost 5000 and it would get some images, and on node 3 it would pull different images and the end result would probably not be what I want. But here, since localhost 5000 routes to our unique registry, I know I will have a consistent result. That makes sense? Yeah. Oh, what happens if I put replicas for the registry? Bad things, because in that case I would end up with 2 copies of the registry, and so like some layers will end up on one registry, some on the other one. So that would be, yeah, it would be a little bit like sending half of the traffic to a different web server, but having those web servers talk to different databases. So, yeah. Right. How does the localhost 5000 thing works? Okay, so when I created the registry, I gave the -- publish 5000 colon 5000, which means publish means I want that service to be available everywhere on all my nodes. And since I specified 5000 colon 5000, that means port 5000 on all my nodes is going to map to port 5000, sorry, in this container. So when I do that on all my nodes, all my 5 nodes, I get a load balancer listening on port 5000 and routing traffic to my registry container. under the hood, that load balancer is using IPVS, and then the traffic is carried by the ingress overlay network. So that's what I said. It's a kind of DMZ network, and then it goes to my registry container.
So that load balancer has the read address.
Yes. That load balancer knows the actual address of the registry container. And in that case, it's a kind of, I don't know how to call that. It's a kind of the opposite of a load balancer because I have only one backend and I have 5 frontends. So it's more like a kind of proxy thing. Yeah. All right, let's try this. Yeah, it was v0.1, so I should be good. Okay, so now I do docker service ls, and it tells me that everything is already up and running. So I would love to connect to the web UI and see like what's going on, except I can't because the web UI is not exposed at this point. Well, I could kind of break into the network and do curl or whatever, but I want to connect with my browser. So I'm going to expose the, right, let's skip that. I'm going to expose my web UI. So I'm going to update the service definition of web UI. The only difference will be I want to map port 8000 on my cluster to port 80 in the web UI container. So now when I connect to any node on port 8000, I get routed to the web UI. Let's do it. Docker service update web UI -- publish add 8000:80. So when I do that, then I'm going to do Docker service ps web UI. And then here I see something a little bit weird. Like, see, I have a, I paused the thing. Well, I can probably, I can. So you could expect that dynamically it's going to like open a port and forward, etc. But no, what it did is that it shut down the old version of the service, the one that was purely internal, and it created instead a new version that is exposed to the network. And each time you do Docker service update, it will replace the old task with a new task and create new containers. Even for changes that are trivial, like if it's just like your, I don't know, like you're changing the quota of RAM or something like that, and it will still recreate a new thing. Why? There is a very good reason for that. Well, that's because even if at first it could seem like a good idea that if we can change the container in place, we should do it, but then it means that you get inconsistent behavior. Imagine this. You are on your local machine or just on one unique node, and you're doing Docker service update and changing a bunch of stuff. And since everything is on the same node, most likely, most of the times, there will be no requirement to restart the containers. So when you develop, you're used to Docker service update, dynamically update some parameter, and you're fine. And then you go to production on a cluster with multiple nodes. And now when you do Docker service update, you're changing memory size and you're doing operations that need the container to be moved somewhere else. Because for instance, you increase the memory size and now it doesn't fit on that machine, so you want to, it will move on a different machine. And so now suddenly, those operations that used to not restart the container, now they restart the container. So that would be inconsistent. So that's why we decided to be a little bit like strict and rigid. Docker service update will always restart containers. And yeah, sometimes it's annoying, especially for databases and stuff like that, but there are ways to work around it. And to be kind of realistic, even for databases and things like that, like when you think about, I'm going to do Docker service update to, I don't know, like increase the memory allocation. Sometimes it will work directly because you have enough memory on the local node, but sometimes it will require to move the container somewhere else. And that's inconsistent, and that's super dangerous because at first you try your magic like database automatic resizing memory thing, and it works great. And then when you go to production and it actually has to move things around, everything breaks because now the containers get restarted. So better immediately get used to the fact that containers can be restarted and work with that in mind. Okay, so now normally if I connect to port 8000 on any of my nodes, I should be able to see my web interface. And yep, that's the case. And that super weird graph is a side effect of the fact that I'm not a front-end developer. So I'm just going to reload that page and we will get the good old display that we had in the very beginning. So at this point, we have exactly what we had in the very beginning when you did Docker Compose up, except it's running using SwarmKit concepts. Yes?